up everybody, my name is Moss, and welcome back to this tutorial series on GitLab. We've introduced you to GitLab pipelines, but you may be in a situation where your team is already using Jenkins pipelines to facilitate CI/CD. This means that you already have pipelines defined, and you need to convert those Jenkins pipelines into their GitLab pipeline equivalent while taking advantage of GitLab's most useful CI/CD features. Before migrating any of your pipelines, you'll need to understand some key differences in how these tools facilitate CI/CD. In this video, I'll show you how to migrate to GitLab CI/CD from Jenkins pipelines. Let's quickly review our learning objectives. After completing this video, you should be able to do the following. Explain the differences between Jenkins pipelines and GitLab CI/CD. Migrate your own Jenkins pipelines to GitLab pipelines. And use GitLab pipelines to run tests on the LambdaTest Selenium Automation Grid. There are a couple of prerequisites that you will need before starting the tutorial. The first is familiarity with Jenkins pipelines and terminology. You will also need a LambdaTest account. Let's begin the tutorial by performing a comparison of terminology and concepts between the two tools. We will define a mapping of terms between declarative Jenkins pipelines and GitLab CI/CD. We will refer to Jenkins terms and draw a mapping from that term to its equivalent in GitLab. The first is the agent section of a Jenkins pipeline. This section of the pipeline specifies which Jenkins agents should execute the pipeline. In GitLab, we use what are known as GitLab runners, which execute jobs in a GitLab pipeline. Jenkins agents and GitLab runners do have differences, but they serve very similar roles in their respective tools. Both are software applications that execute tasks defined in a pipeline. Next is the Jenkins stages section. Jenkins and GitLab share the concept of stages in their pipelines. In both tools, stages define the chronological order of a pipeline execution. However, in GitLab, stages are enumerated in a list at the top of the pipeline definition. We then have the steps section of a Jenkins pipeline. The steps section of a Jenkins pipeline allows you to define commands to be executed by the Jenkins agent. In GitLab, we can use the equivalent script section in a GitLab pipeline. There are two important Jenkins directives which you have likely used in the past. The first is the environment directive. This Jenkins directive will allow you to define environment variables that will be available during pipeline runtime. The variables keyword in GitLab provides equivalent functionality as the Jenkins environment directive. The last one is the Jenkins tools directive. This Jenkins directive allows you to install tools that are necessary to execute the pipeline steps. However, there is no equivalent in GitLab for the tools directive, and instead GitLab recommends using pre-built Docker container images. Now that we've defined this mapping between the tools, let's move on to the next part of the tutorial. Okay, so the first thing that I want to do is walk through the code base that we're going to be using. And once we've reviewed the code base, then we'll walk through the Jenkins pipeline that tests this code base. And after walking through the Jenkins pipeline code, we'll then write an equivalent GitLab pipeline together. This will demonstrate a simple migration from a Jenkins pipeline to a GitLab pipeline, but hopefully it will highlight some of the key differences that I mentioned during the presentation. In the pipeline that we write, we'll utilize the LambdaTest Selenium Automation Grid in order to execute the tests that are defined in this code base. So let's start walking through the code base. I'm in GitLab and I'm currently inside of the project, which is called Automation Demo. Automation Demo is a Maven project that utilizes TestNG as its testing framework. And what you'll notice under the source directory is that there is only a test directory. There is no main directory, and that's because there's no application for this code base. This is just a test class. This code base contains only a single Java test class, and it's testing a website, a public website out on the internet. So let's navigate into the test directory and take a look at the test class. So we have a single test class called automation demo test.java. So I'll open up that file. And in this test class, we have three methods. The first is the test setup method. And then we have a single test method called test element addition. And then we have a teardown method. So the test setup method is parameterized and it runs before our single test method. The first thing that the test setup method does is set the desired capabilities, and the capabilities are parameterized. We get these parameters from the test-ng configuration, XML configuration. And after setting the desired capabilities, it then generates a new remote WebDriver, and it uses the LambdaTest hub URL. Now these capabilities are parameterized, but if you wanted to, you could actually use the capabilities generator that is provided by LambdaTest to automatically generate this code that sets the desired capabilities. I have the capabilities generator already pulled up in a tab, but you can Google search LambdaTest capabilities generator, and it should pull up as the first result. And you can see here the capabilities generator right here. So I'll navigate to this page. And from here, I can select which language I want the capabilities to be generated in. In our case, it would be Java. And then I can select Selenium or Selenium 4. And then I could just copy this code into my test class. So I'll navigate back to the test class. And under where the capabilities are defined, you can see that it creates a new remote WebDriver. And here it lists the hub URL, and it concatenates it using the username and access key variables, which are defined up here. So my username for my LambdaTest account is Tech with Moss, and then I have my account access key defined as an environment variable, which is called LT_access_token. Now you might be wondering, where does this hub URL come from? And we can actually retrieve the full URL, which includes the username and access key, from the capabilities generator. So if I navigate back to the generator, you can see in the right-hand side here, access key. If I click that, we have the username, the access key, and then we have the full hub URL, which includes username and access key. And I could copy that to my clipboard, and I could also use that here with everything hard-coded. And once the test setup method completes, we then run this single test method called test element addition, which connects to, using the driver, connects to this test URL, and the test URL is just todomvc.com. So if I were to navigate to this URL, let's open it up in a new tab. It's a very simple to-do list application. So if I just say to-do 1 and hit enter, it adds this as an item in a to-do list. And then I can check each item and mark it as completed. And then I can clear those items. Okay. So if I scroll back to our test method, after connecting to the test URL, the test method then adds 5 items to the to-do list. So you can see here in the for loop, it adds 5 items, and then after it adds those items, it iterates over that list, and for each item, it marks it as complete and then deletes that item from the list. And once our test method completes, the teardown method is called and it quits the driver. Okay, so now that we've walked through the test class, let's navigate back to the repository. And real quickly, I want to show the test.ng XML file so that we can see how our tests are configured. And inside of our XML file, you can see that there are 3 test scenarios defined. In the first test scenario, we're using Chrome on Windows. And in the second scenario, we're using Firefox on Windows. And then in the last one, we're using Microsoft Edge on Mac OS. So now let's navigate back to the repository. And you can see in the repository, I have a Jenkins file defined, a Jenkins pipeline. So let's take a look at this Jenkins pipeline. So this is a pretty simple pipeline. It has a single stage called the test stage, and it begins by specifying that it can run on any available Jenkins agent. And then after the agent section, it then defines an environment section. And in the environment section, we define two environment variables, LambdaTest underscore username, which is my LambdaTest account username, and then Maven CLI options. Okay, and we run it in batch mode, and then we specify the test.ng configuration XML file. And inside of the test stage, we have the steps section. And inside of steps, we invoke the pipeline Maven integration plugin using the with Maven statement. And with that invocation, we specify the Maven installation, and we also specify some additional options. In this case, we specify the JUnit publisher. So this is also using the JUnit Jenkins plugin in order to publish JUnit reports visually in the Jenkins UI. And inside of the with Maven statement, we invoke with credentials and specify some Jenkins credentials called LambdaTest access token. So I created a Jenkins credential to store my LambdaTest account access token. And we're making that access token value available as an environment variable called LT underscore access underscore token. So now in the innermost statement, we invoke shell and call Maven with our Maven CLI options and then the test command. And if I navigate to Jenkins, I actually ran this pipeline already. If I take a look at the console output, you can see where it invokes the pipeline Maven integration plugin. It masks the environment variable LT access token, and then it calls Maven with those CLI options and the test command. And if I scroll down, we can see where the tests begin, and you can see it makes a connection to the remote WebDriver, and it runs those tests on the LambdaTest Selenium Automation Grid, and it finishes successfully. After the build finishes, you can see where the pipeline Maven integration plugin then publishes the JUnit reports. And if we navigate back to the build page, you can see here that we can review the test results of the pipeline. So if I navigate into the test class, we have the same test method, but it was executed 3 times for each of our test scenarios. And if I navigate to the pipeline page, we also get the test result trend graph here as well. In this case, we only have one result. Okay, so now let's navigate back to GitLab, and we've walked through the Jenkins pipeline. So now let's write an equivalent GitLab pipeline. So from here, I'm going to navigate to the cicd section of the repository, and we'll open up the pipeline editor. So I'm going to open this up in a new tab. Then I'll select Create New CI/CD Pipeline. And we'll start with this basic template, but we are going to delete the majority of it. So we'll only have one stage. So I'm going to go ahead and delete these comments. And I'll leave only the test stage. So I'll delete the build stage, the deploy stage. Okay. And we'll leave one test job. Okay. Now when the GitLab runner executes this test job, it's going to invoke Maven commands. So Maven needs to be available somehow to the GitLab runner. And in the case of Jenkins, I installed Maven on the Jenkins controller node. So when we invoked the pipeline Maven integration plugin, we were able to reference a specific Maven installation that the plugin could use to execute Maven commands. But as I mentioned in the presentation, GitLab recommends using pre-built Docker container images that have all of your dependencies already installed on the image. And we can specify a Docker image in a pipeline that a GitLab runner should use to execute the script section of a particular job. And not only that, we can specify default images at the top level of the pipeline, but we can also specify Docker images per job in the pipeline. So if a particular job needs to utilize a specific Docker image, we can also specify those images under a job definition within the pipeline, and that will override any of the images that are defined as the default images in the top level of the pipeline. In our case, we're going to use the default image throughout the whole pipeline. And to define an image, we use the image keyword. And then we specify the name of the image as well as the tag. In this case, we're going to use the Maven image, and we'll use the latest version of the Maven image. Now, after specifying the Docker image, we need to replicate the environment directive in our Jenkins pipeline. So if we go back to the Jenkins pipeline, we have this environment directive where we define two variables, the username and then the Maven CLI options. So we need to replicate that in our pipeline, and to do that, we can use the variables keyword. So following the image definition, I will use the variables keyword, and under variables, we'll first define the username environment variable. And after the username variable, we have Maven CLI options. And here we're just going to specify batch mode. So it will run Maven in a non-interactive mode so that it doesn't prompt the user for input. And then we will specify the test.ng XML file. And finally, we'll specify a Maven options variable. And here we're going to specify the local repo is equal to, and then I'm going to use a predefined environment variable, CI_project directory .m2, and then repository. And similar to the last video, we need to cache the dependencies that Maven downloads when running Maven commands, so that when the pipeline runs, it's running in a fresh environment. We don't want it to re-download all of the Maven dependencies. So we want to make sure that we cache that, and that is a difference between the GitLab pipeline and the Jenkins pipeline. The Jenkins pipeline is a shared workspace that's going to exist between pipeline runs unless we explicitly tell it to utilize a fresh workspace. So below the variables section, I'm going to use the cache keyword, and below cache, I'll specify the file paths that I want to cache. So I'm going to use the paths keyword, and below paths, I will specify .m2 and then repository. Okay, so now that we're caching the Maven dependencies, let's move to the test job, and I'm going to remove these scripts. I'll also remove these comments. And under the script section, we're going to invoke Maven. So here I'll say Maven and then $, and we'll reference our environment variable, Maven CLI options, and then the test command. So that's everything that we need for the script section, but we do also want to produce JUnit reports as well. And we can generate those reports using the artifacts keyword. So below the script section, I'm going to use the artifacts keyword. And then under artifacts, we'll first specify the when condition, when these artifacts should be produced. And we're going to say always. And under the when condition, we'll specify what kind of artifact. And this will be reports. And under reports, we'll specify JUnit as the type of report. And finally, under the JUnit keyword, we would specify the path to our Surefire reports. So I'm going to say target, and then Surefire reports, and then test hyphen, then asterisk, and then .xml. And that's pretty much all we need inside of the pipeline definition, but we are missing one environment variable, and that is the LambdaTest access token environment variable. So in Jenkins, we saved that value as a Jenkins credential, and then in the Jenkins pipeline, we invoked the with credentials function to use the access token as an environment variable. In the case of GitLab, we can define those kinds of environment variables that shouldn't be checked into version control in the settings of the repository and then under the CI/CD section. So let's go ahead and open that up. And from here, let's expand the variables section. And I'll select add variable. And we'll call it LT underscore access token. And to retrieve the value, I'll navigate back to the LambdaTest capabilities generator. And I'll select access key. And then I'm going to copy the access key value to my clipboard. Okay. And I'll navigate back to GitLab, and we'll paste that value in. And this is of type variable, and we'll keep the environment scope the same. It's protected, but we also want this variable masked as well. And masking this variable means that it will be, its value won't be revealed in the pipeline job logs. So I'll go ahead and select add variable. And you can see in the UI that the value of the variable isn't revealed. Okay, so now let's navigate back to the pipeline editor. And there's one thing that I'd like to point out that is a really important difference between GitLab pipelines and Jenkins pipelines. So in GitLab, if we were to have multiple stages, for instance, before the test stage, let's say we had a build stage where we compiled code, the compiled program would be an artifact that would be used during the test stage. However, each of the jobs that are ran in their respective stages are being ran in a fresh environment. It's not a shared workspace. So the compiled program that was generated during the build stage would not be available to jobs in the test stage. So if artifacts are produced in a particular stage that a downstream stage are dependent on, then what we need to do is use the artifacts keyword to specify those artifacts that were produced in the upstream stage. What happens when we use the artifacts keyword is the artifacts that we specify are uploaded to GitLab by the GitLab runner. And by default, those artifacts are downloaded by downstream jobs. So this default behavior is different than in Jenkins pipelines, where in a Jenkins pipeline, you have a Jenkins agent running all stages of the pipeline in a shared workspace, unless we explicitly state in the pipeline to use different Jenkins agents for each of the pipeline stages. And there is a nice example of the artifacts keyword usage in the GitLab documentation that I'd like to quickly show. So if we Google search artifacts GitLab keyword, and I'll select the artifacts keyword. If I scroll down to this code snippet, you can see part of a pipeline definition here. And we have 4 pipeline jobs defined. We have 2 build jobs for 2 different platforms and 2 test jobs for each of those platforms. So for the OSX build, it produces a set of binaries. And you can see here how the artifacts keyword is used. Under artifacts, they specify paths to produce as artifacts, and then the binaries directory. And we have the same definition for the Linux platform build as well. And then if we take a look at the test jobs, what you'll notice is this dependencies keyword. So the default behavior is all artifacts that were produced in previous upstream stages will automatically be downloaded by a job. So for instance, in the deploy stage here, this is going to download all of the artifacts that were previously produced. However, if a job only needs a subset of artifacts that were produced in prior stages, then what you can do is specify the dependencies keyword. And so in the case of testing the OSX platform, all we need are the binaries from the OSX build job. So under the dependencies keyword, we specify the job name that produced those artifacts. And you can see that the same thing happens for the test job for the Linux platform. The dependencies that are specified here are the artifacts from the build job for the Linux platform. So I did want to quickly detour because I do think this is a very important difference between Jenkins pipelines and GitLab pipelines, and it's a use case that you'll likely run into if you need to compile your application. And even if you didn't have to compile your application, you're likely producing artifacts in an upstream stage that need to be shared with downstream stages. So let's navigate back to our GitLab pipeline, and I'll remove this build stage since we won't be using that. And let's quickly do a side-by-side comparison of our GitLab pipeline and our Jenkins pipeline just to make sure that we've covered everything that was defined in the Jenkins pipeline. So I'll pull this Jenkins pipeline out into a new window. Okay. So starting from the top, we have the top level pipeline definition. Then we have agent any, so this can run on any Jenkins agent. Here we don't have an agent section. We're just specifying the image that should be used by the GitLab runner when executing the commands defined in our script section. And then for the environment directive in our Jenkins pipeline, we have the equivalent of variables keyword to define our environment variables in the pipeline. In the Jenkins pipeline, we don't need to specify the Maven options variable. We're using the pipeline Maven integration plugin here. And then we also have the cache statement in our GitLab pipeline, which we don't have to specify in the Jenkins pipeline because it's using a shared workspace across the whole pipeline and between pipeline runs. So unless we clear that workspace, we won't have to re-download the Maven dependencies every time we run the Jenkins pipeline. So in GitLab, we do need to specify the cache keyword so that we're not re-downloading those Maven dependencies on each run. Then we have the stages definition in our Jenkins pipeline with just the single test stage. Here we have the stages definition and then a single test job that is associated with the test stage. And then in the steps section, we invoke with Maven, and we specify the Maven installation that we want to use, and we say that we want to also utilize the JUnit publisher. And then we invoke the with credentials function to specify the access token credentials as an environment variable. And here in the GitLab pipeline, since we're using the Docker image, the Maven Docker image, we don't have to specify, with Maven or anything like that, or a Maven installation. This is going to be ran inside of the Maven Docker container. So here we invoke the Maven test command with our CLI options. And finally, we produce the artifacts from the test job, which in this case are JUnit test reports. Here we're specifying the JUnit publisher using the pipeline Maven integration plugin. Now I do want to mention that I wrote this Jenkins pipeline this way because we're using a Maven project. And since we're using a Maven project, it's best to use the pipeline Maven integration plugin. But even without the plugin, we could still do the same thing that we're doing here for our Maven project. And I have an alternate version of the pipeline in this repository as well. So it's called Jenkins file old. And if we open this up, the first difference that you'll see between the two Jenkins pipelines is that here I'm using the tools directive to specify a Maven installation and a JDK. And I'm also specifying the Maven options environment variable as well. So I guess you could say this is a more generic version of the pipeline because maybe your tool dependency isn't Maven or the JDK. Maybe your tool dependency is that Python 2.7 or Python 3 is installed for you to be able to run the steps in the Jenkins pipeline. And if you recall from the presentation, GitLab does not have an equivalent for this tools directive where we can specify tools that should be installed or present on the Jenkins agent that is executing the steps defined in the pipeline. Instead, in GitLab, we're using Docker images to perform the same role as the tools directive. And that gives us somewhat similar functionality to the image keyword in our GitLab pipeline. And to show an example, if I search for Docker pipeline plugin and then CloudBees, they actually have an article that specifies how you can run a Docker image kind of the same way you run it here. You can see we're invoking docker.image. We're specifying the image name and a version. And then inside of this block, we download the source code and then we execute Maven. So this is happening within the Docker container, similar to how this script is being executed inside of a Docker container. So this is another alternative method to writing our Jenkins pipeline, but it does require the Docker pipeline plugin to be present on the Jenkins instance. And I think that's what I like about GitLab in this case. Even though it's great that Jenkins is an extensible tool, in the case of GitLab, none of this functionality is provided through plugins. It's just there by default. Okay, so let's go ahead and commit our GitLab pipeline. I'm going to exit out of these windows. And we will commit these changes, which should trigger a pipeline to automatically run. So we should see it pop up here in a second. And you can see that a pipeline is now running. So I can select View Pipeline. And we have the test job running. So I'll go ahead and open up the test job. And let's see where it's at. Okay, so it looks like the job has downloaded the Maven dependencies, and then it started the tests. And you can see down here that it began a session with the remote WebDriver to execute the tests. And 3 tests ran, and there were 0 failures, so there was a successful build. And then it creates the cache, and then it also uploads artifacts, which in this case are the Surefire, the JUnit test reports. And in the first run of the pipeline, we would expect to see the download of Maven dependencies, but in future runs of the pipeline, those dependencies should be cached, so they won't be re-downloaded. So I'll navigate to the pipelines section. And the first thing that I'd like to point out from the pipeline page is next to our pipeline, we have this artifacts drop down here where we can download the artifacts that were generated from the pipeline. In this case, we just have the JUnit test reports. If I navigate into the pipeline, we have the visual graphical view of the pipeline execution, but under the tests section, we can also see the results of the test execution in the pipeline. So we have a 100% success rate. We can see which jobs executed tests. If I go into the test job, it tells us the test class name, as well as the name of the test, and then the status of that test and how long that test, or the duration of that particular test. Now this test uses the LambdaTest Selenium Automation Grid as the remote web driver. So if we navigate to our LambdaTest account, we should be able to see the results of the tests and the test scenarios in our LambdaTest account. And the results of those tests are recorded, and we can access those recordings from the left-hand menu here. If I select automation, it'll take us to the automation page where we can view a timeline of test results. So I'll click on the most recent here. And from the automation logs tab, we can view the results of each of our test scenarios. We had 3 test scenarios defined, one for Windows 10 on Firefox version 93, one for Windows 10 on Chrome version 94, and then the final one is Mac OS, and then that's on running on Microsoft Edge version 94. So for each of these test scenarios, we can view the recording of that scenario. So if I select play, we can see the website that we're connecting to in our tests, and then it adds 5 items to the to-do list. And once those 5 items are added, it begins checking them off and marking them as completed, which clears the item from the list. Okay, and then that concludes the test scenario. And I won't go through each one, but you can see in each of the test scenarios, we have the test scenario successfully completing the tests defined in our test class. And for each of these scenarios, we can use the tabs up here to dive deeper into the details of the test scenario execution in the event that maybe the scenario failed and we had to perform debugging. Then we can explore all of the details of the scenario from these tabs. So I'm going to navigate back to our GitLab project. And I think that wraps up everything that I wanted to cover. So I hope you enjoyed this video, and I will see you in the next one. If you'd like to learn more, be sure to follow our blog at lambdatest.com/blog, as well as our LambdaTest community at community.lambdatest.com. You can also earn resume-worthy LambdaTest Selenium certifications at lambdatest.com/certifications.